Hey guys, this is Mrs. Harbin, and this is Algebra 2 presentation for section 2.2 graphs of linear equations. We talked last presentation about the Cartesian plane and graphing in the Cartesian plane. Linear just means line, and equations we know are two expressions that equal to each other. So we're going to basically be graphing using equations, creating drawings of straight lines. That's what all of that means. Our biblical integration is this. Relationships exist everywhere. God desires us to encourage each other and have a relationship with other Christians in order that we may all share in the glory of Christ. In math, we have relationships between numbers. When we look at our ordered pairs, we had a relationship between that x value and that y value. The y value is determined by the x value. So we see relationships all throughout math and science and in our own personal relationships. Our lesson objective for today is this. You, the student, I lost my mouse there, will identify the slope and the x and y intercepts of a line, plus interpret the slope as a rate of change. So let's first talk about what a linear function is. It is a first-degree polynomial function whose graph is a line. Let's go over some of those things first of all. A function, if you remember, a function is when you have an x value and you plug it into an equation, and after you plug and chug, you get a y value. That's a function. Linear just makes a straight line. So when we plug in these x values, we're going to get y values, and when we graph them, we'll get a straight line. A first-degree polynomial means that it has a bunch of terms, hopefully you remember what a term is, and that the highest exponent in any of those terms is a 1. So it might look like this, 3x plus 2. We have a polynomial, we have two terms, and the highest exponent here, x to the first power, is 1. So it's a first-degree polynomial whose function is a line. If we have an exponent of 2 or 3 or something else for that variable, then it's no longer a linear function. And we'll learn about those types of functions later. But let's stick with linear functions for now. The standard form of a linear function or a linear equation is ax plus by equals c. A, B, and C, those capitals are integers. Remember, integers are your negatives, your 0, and your positives. 1, 2, 3, 4, 5, 6, 7, 8, what have you. So A, B, and C are integers when possible, and A and B are not both 0. A is usually positive. The intercepts, when we talk about finding the x and y intercepts, the intercepts are the points at which the graph intersects the x and y axes. So if I'm going to draw a graph over here really quickly, and let's change my line color so it's a little bit different from the graph itself. Let's say I draw this linear equation. I graph my x and my y points, I connect the dots. This is the line that I get. It crosses the x-axis right here. This is my x-intercept. And it crosses the y-axis right here. At the y, that is my y-intercept. Now think for a second. When it crosses the x-axis, what is the value of y? Hopefully you said that at the x-intercept, y equals 0. At the x-intercept, y equals 0. It's not up or down. It's right on the axis. What about here? When it crosses the y-intercept, what is x? Hopefully you said x equals 0. Again, it's crossing the y-intercept. It's neither left nor right on the axis. It's just right on y, so x equals 0. That information can help us find the x and y intercept. If we substitute 0 in for y, that will tell us the x-intercept. And if we substitute 0 in for x in our equation, we can find the y-intercept. And we will be doing some of that. The slope of a line, represented by the letter m, is the ratio of its rise, the vertical change, to the corresponding run, horizontal change. Now, slope is something that you've heard before. If you play golf, you've heard about the slope of your the fairway as you approach the green. If you are driving or if you're around people that are doing road construction, or maybe your parents built a house and you heard them talking about the slope of your driveway or the slope of your roof. Basically, it's how steep something is. It's the ratio of its vertical change, vertical being up and down, compared to its horizontal change, rise over run, or how steep it is. We represent slope like this, rise over run. We measure the change in rise by subtracting our y values, the second y value minus the first y value, and we measure the change in run with our second x value minus our second y value. We can also say delta y over delta x. Delta just means, that little triangle, Greek symbol there, just means the change in something. The change in y over the change in x. So let's find the slope here. Here we've got our x2 and our y2, our x1 and our y1. Okay, according to our formula, delta y is y2 minus y1 over x2 minus x1. And our values, our coordinates are here, 5 and 5 and 3 and 2. It doesn't matter if we start here and subtract this way or start here and go this way, as long as we do it consistently for both. So if we're going to start with 2 first and subtract 5 on the top, then on the bottom when we get to x values we need to start with 3 and subtract 5. We can go the other way and we would get the same answer, but we do need to be consistent the direction that we're going. In this case we get negative 3 over negative 2, and those two negatives make a positive. So our slope is 3 over 2, which basically means that for every 3 spots up, I'm going to go to the right 2. So I'm here and I go 1, 2, 3 spots up and over 2. Rise over run. Let's find the slope of a line passing through negative 8, 5, and 4, negative 3. These are my two y values and these are my two x values. I can take 5 minus 3 as long as I also do, or 5 minus negative 3 as long as I also go negative 8 minus 4, or I can go the other way. Negative 3 minus 5, as long as I start over here for the second one. 4 minus negative 8. For ours, we're going to do 3 minus negative 5 and 4 minus negative 8, which is negative 8 over 12, which simplifies to negative 2 over 3. The order in which the points are chosen has no effect on the slope. Remember, that's what I was saying. You can start with either set of coordinates first, as long as you do that consistently. If you start with your second ordered pair, then you need to do that for both the top and the bottom. The sign of the slope indicates whether the line slants up or down when moving from left to right. So we had two different slopes. One was positive and one was negative in our previous examples, and that's telling us whether the slant is going up, whether it's an uphill climb or a downhill slant. The absolute value of the slope indicates the steepness of the line. So let's take a look. When we have a positive slope, like in our first example, we had positive 3 over 2. Positive slope is uphill. A negative slope, like in our second example, means that we are going downhill from left to right. If your slope equals 0, if something has no slope, it is flat. Well, it should look like a horizontal line. It has no slope. And if something is vertical, the slope is undefined. There is no rise over run, there's only rise. And in that case, we can't define the slope. You have to rise before you can run. There's just a little reminder to help you remember that rise is first, the y value is first, up and down, over the run, which is left and right. Hey, this is Slope Man. You've seen this face before, maybe. It will be on a picture in our classroom to help you remember that a positive slope goes upwards from left to right. A negative slope goes downhill from left to right. A straight up and down line has no rise over run, so it is undefined. And a straight line has 0 slope because it's not slanted at all. It's just a flat line. Slope does measure rate of change. It compares two changing quantities. So really important to remember that. And a lot of times when we're dealing with slope, we're going to write our equation in slope-intercept form of a linear equation, which is y equals mx plus b. This is one of those math equations, kind of like the Pythagorean theorem, that you will need to know and be able to use without always referencing a formula chart. We know what y is. M is our slope. X is our x coordinate or x value in the ordered pair. And b is our y-intercept, where it crosses the y-axis. All right, today we looked at these things. We identified the slope using delta y over delta x and the x and y intercepts of a line. We plugged in 0 for y when it crosses the x-axis, and we plug in 0 for x when it crosses the y-axis. Plus, we interpreted the slope as a rate of change, and we looked at whether a slope was positive, negative, 0, or undefined. We'll continue to practice this in class. If you guys have any questions, be sure to ask me next class.